Okay, last rational functions problem. I know these are a lot of work, but they are worth it in the end. It's worth it having nice points on your graph. Okay, so I'm going to go ahead and factor, although this is a top-heavy fraction. I'm going to go ahead and factor. My numerator, if I'm multiplying to 8 and adding to negative 9, this is going to factor x minus 8, x minus 1. I don't have anything that cancels, but I do have a nice situation here for finding my x-intercepts now. So my x-intercepts come from setting both of those equal to 0. So I have two x-intercepts for this function. One is 8, 0, and the other is 1, 0. And just like I have with the other two problems, I'm going to plot as I go. So 1, 0, and 8, 0. Oh, well, we'll just pretend like that. That's there for you. Okay, so y-intercepts. Y-intercepts what we get when we put zeros in for our x's. So 0 squared minus 9 times 0 plus 8 over 0 minus 2. So our zeros cancel. Doesn't matter, doesn't matter, doesn't matter. I have 8 over negative 2, which means my y-intercept is going to be negative 4. Starting to get a picture of what this rational function looks like. No removable discontinuities for this function because we don't have anything that cancels. Our vertical asymptote is x equals 2. And I know that I'm going to have a slant asymptote for this problem because my function is top-heavy. To find that slant asymptote, we're going to synthetically divide our numerator by our vertical asymptote. Quick little math here. 1, negative 9, and 8. Bring down your 1. Multiply. 2 times 1 is, sorry, that kind of looks like a plus. 2 times 1 is 2, and then add vertically. Negative 9 plus 2 is negative 7. And you do not care about the remainder when you're finding your vertical or your slant asymptote. If you started out with squares, which we did here, you end up with your line, and that's what you want. If you can have, like, there are times where if you have an x cubed over x squared, you can't cancel. Sorry about the bell. You do have to synthetically divide twice. Okay, so we have our horizontal asymptote for this problem is actually a slant asymptote, and the y-intercept is negative 7, and our slope is 1 over 1, so up 1 over 1. Okay, we have a pretty good picture of what's going on the left side of our of 2, but I don't really know what's going on the right side. So let's fill in some blanks by doing a table and make sure we can get some of these values going here. So I have what's going on at 0. I have 1, and that gives me a good picture again from the left. So as my graph is approaching 2 from the left, my graph is going to positive infinity. As my graph is approaching 2 from the right, I think that it's going to do something like this because of where that x-intercept is. But I'm going to confirm that with a table here. So I have what's going on at 8. I'm really more interested in 3 and 4 though. So just like we have for our other problems, 2 is where our asymptote is. Let's see what's going on at 3. Let's see what's going on at 4 and see if we can fill in the blanks here. All right. You can use factored form, or you can use the form with x squared in it. I think I'll use factored form. All right, so I'm going to do 3 minus 8 over 3, or times 3 minus 1 over 3 minus 2. So my denominator is going to be 1, and in my numerator I have negative 5 times positive 2. So that value at 3, my x value, or my y value, is going to be negative 10. So it's going to be way down. And let's see what's happening at 4. Same deal. 4 minus 8. 4 minus 1 over 4 minus 2. 4 minus 8 is negative 4. 4 minus 1 is positive 3, so that's negative 12 over 2, which is negative 6. So at 4, my y value is negative 6. So if we play a little connect the dots here, on the right side of our function, our graph is going to negative infinity. So the limit as x approaches 2 from the left of our function is positive infinity. The limit as x approaches 2 from the right of our function is negative infinity. So the two-sided limit does not exist. But we know the behavior of the graph, and that's really what was important to us. All right, I hope that helps.